to talk about a specific project, as I mentioned, which is Whittle Reserve. So this is a skate park on Churchill Road, existing skate park that we had on Churchill Road that was flagged for a renewal, and it was basically the whole site that was going to be redeveloped as part of the open space strategy that council had. And to look at the overall project, it was a big concern of that was flood mitigation and flood management in that area. So in terms of a bit of an overview, I'll walk through the flood risk component to the project and how it influenced the design. I'll talk about the original design that was put for construction. Funny enough, when I first came to council, I was given about a week, and then a week after that they said, here's your first project, which was Whittle Reserve. So it was all designed, it was ready to go, and there were some changes along the way, which ended up resulting in a revised design, and a revised design that was actually a better outcome in the end, and was around the soakage trench and permeable pavement. In terms of flood risk in that area, the site, as you can see, is highlighted in red. So it's just off Churchill Road and runs parallel to our council boundary of Devonport Terrace and the rail corridor. The flood risk is quite evident in terms of, you can see here, this 1% AEP flood map, and it shows the problematic areas that we've got along this corridor. A lot of that is obviously because of the urban infill in that area, and it's going to continue to grow. The other issue for Prospect and its uniqueness is that there aren't any natural waterways that cross through City of Prospect. So all of our drainage is subsurface, so pits and pipes. So it's quite a challenge for us in managing stormwater. So this project specifically, the existing stormwater management was everything was contained on site, and we really wanted to stick towards that and make sure we weren't increasing the flood risk in the area by basically discharging that into the stormwater system. So we've got a large culvert that runs all the way down Churchill Road, ties in with a whole series of other major culverts and pipes, and discharges out into the open channel, heading towards the Barker Inlet wetlands. So with that, we said, yep, we're going to contain everything on site. We're not going to increase the amount of flood risk from this redevelopment of the open space, and keep it contained. So this is a great aerial at the end of the project that we took, and I've just got it in reference against the actual design, civil design and stormwater documentation, so you can compare. So the skate park takes up a lot of the majority of the site in terms of footprint. So it was definitely increased from the existing skate park that was there. We really wanted to have a bit more of an intermediate level for skaters and have some more challenging components to it, which we had Convict on that, they were excellent in terms of design and construction. So the original design, as you can see here, is, hopefully you can see it at the back, but it's the blue overlay is the stormwater system to manage the site's catchment, keeping it again all contained within the footprint of the site. The original design was focused on using existing soakage pits that were actually functioning for the previous skate park and the sports courts that were there. We had about 3 discharge points, one being here closer to Churchill Road, the other a bit further north, which was under the canopy of quite a large gum on site, which is here. You can see that canopy is quite significant. And we had a use of agricultural pipes as well that were discharging some of the runoff into the garden beds that were proposed around the site along the perimeters. What happened once we started construction is we started digging our first runs of pipe to get them in, heading towards the soakage pits. And to our surprise, the surface obviously, and part of the design investigations they were sized accordingly. As soon as we started digging to the greater depths, we found that was not much underneath that. So they were well undersized, and we had a real sticking point in terms of what we do from here. So those 3 points that I've pointed out were far too small we had to look at redesigning on the go in terms of construction, which was quite stressful at the time, but we worked quickly to work out what are our options. One being, well, we can revert back to discharging everything to Churchill Road. An easier option in terms of constructability, given the culvert that was close by, or we could look at, again, retaining everything on site, which is what we did. So with that, we had a redesign done in terms of making sure we had enough capacity to really capture everything that we still had. The issue that we had was the existing locations and being able to develop them to meet the capacity requirements were far too small in terms of designing infrastructure around that. We had tree protection zones all along, as you can see here, all along Churchill Road that we needed to be mindful of. We had the large gum towards the front of the site. So the footprints of keeping those existing locations wasn't feasible. So we then looked to, well, where can we discharge this? Where can we infiltrate this water on site that will meet our capacity requirements and not cause further design implications with trees and design outcomes as well. So design-wise, we didn't change anything in terms of sports, the multi-use sports court, the skate park, all the play equipment areas and the art components all stayed exactly the same. And we looked to have these soakage trench located in the grass area, as you can see here. So it was a slight configuration of the pipe work that we had within the skate park from the exit points, as well as the sports court and the surrounding paths. But ultimately, that we kept agricultural pipes that were still positioned up north. We reduced some of the pipe that was shown down south, but we basically increased that capacity with the soakage trench on that grass area there. The issues that we had, I've mentioned a bit about the capacity. So that was the best location for us in terms of open space without impacting design. We obviously had the issue of tree protection zones because the size of this was quite substantial. In terms of length, it was ended up being about 11 metres in length, 3 metres wide and about 1 metre deep. So quite a large infiltration pit that was going to capture pretty much all the stormwater runoff from the skate park, the sports courts and the surrounding paths. It was designed for a 5-year ARI event, and the other issue that was quite challenging for this project was the low-level contaminated waste that was identified through the geotechnical investigations. So you can see here the areas in red. These were highlighted through the testing phases that they were low-level contaminated waste, and we knew straight away that basically once we were going to excavate anything of this size for the soakage trench, we didn't want to be disposing of that low-level contaminated waste from a budget perspective as well as an environmental perspective. So we contained it outside of that footprint and still managed to meet our capacity requirements. So in more detail, I've just zoomed in so you can get a better picture. So we've got a pickup point of a graded inlet pit which takes flows out to agricultural pipe within the garden bed. So that was slightly altered but still retained in the revised design. We've also got the pickup points again from the other exits of the skate park as well as the sports court, which were all leading to the soakage trench itself. The soakage trench, I'll get to the detail, but it's got two 200mm agricultural pipes running straight through the centre, which provides that flow to that trench. And again, we still retained a small portion of flows from the pedestrian path into the garden beds through another agricultural pipe on the southern side. This shows you the detail. So like I mentioned, it was a 3 metre wide open trench by about 11 metres long and a nominal depth of about 1 metre. We had a sloping grade in that area, which, as you saw in the overall, in the aerial image, is a grassed area. So we had to make sure that our depths did cover that full depth and preempting the fall of the land in that area. The nominal aggregate size was about 40mm that we used, and we had the two 200mm slotted agricultural pipes running centre to that open trench. As part of that, in terms of the contamination and obviously an excess in material that we're going to be boxing out for the soakage system, we utilised that in the early stages of construction by using it as the base layers of the skate park itself. So we pretty much contained all of that soakage trench material on site and capped it within the skate park in the lower lying layers, and then built that up with imported rubble material. So that was a really important outcome in terms of both cost and environmental, that we were able to again contain that within the site itself. In terms of the installation, here's some of the photos when we had excavated. We used the geofabric liner all the way bottoms and sides, and filled that with the aggregate. We've got a junction box on either side of the trench itself with the 2 outflow pipes that enter into the actual trench itself. You can see here a lot more material going in. It was when they boxed it out, it was quite a large hole that was there, so it was a lot of material to bring in. But then once we had filled that, laid all the pipes between the 2 junction boxes that sit either side, we then started to cap that with the soil for the grass area in that space. And as you can see here, we've got once it had all been capped and covered in that area. So basically, to most of the public, they're not wouldn't know exactly what's under there without council's education. So it's really low impact. It really didn't influence any of the design, and you can see that's the grassed area that was installed on top of that soakage trench. Leading in from that, we also had a permeable pavement design around that large gum that's at the northern portion of the site. So this is quite a significant tree and very important to the design outcomes of Whittle Reserve. So you can see here we had a proposed deck seating area around the tree. So we had a modified pad footing design that really didn't intrude onto the root systems in that area. And the other issue that we had was the amount of density of roots within this zone, hence the design outcome of having a permeable pavement to still provide some infiltration into the root zones. So you can see here the installation of the permeable resin-bound paving. So a base layer which was quite thin in certain areas. As obviously we got closer to the structural root zones, we really minimised that impact, and we're basically putting the base course on top of existing surface. So it was really minimal excavation in that area, and really increasing the amount of catchment of stormwater runoff within that drip zone of the tree. There's the finished product. So you can see it's quite a large area that runs off. The colour we matched to the exposed aggregate path that runs right around the site, and that was to keep that same design intent but have the functioning purpose of water infiltration into that area. And here's some of the photos of just the overall product. It's a project that I'm very proud of in terms of design outcomes from a water sensitive urban design perspective, but just as a general upgrade for our community. It's something that's well loved, it's well used. Most days when you go past, you will see kids and even adults out there that are either skateboarding, riding their bikes or scooters, and it's a really popular venue that we continue to activate. So that's the skate park itself. Again, some of those more challenging elements and quarter pipes that were ratings that were provided into the design, whereas previously it was quite a beginner level skate park design. So we wanted to push the boundaries in that regard. We incorporated our art and play equipment components to it, and had the multi-use sports court all in the southern portion of the site. So if there's any questions, I'm happy to take them, otherwise...
Can you just explain the design of the permeable surface? It's not obvious to my naked eye.
Yep.
that permeability of that material?
So the question was, can I explain the design of the permeable pavement around the trees? So what we looked at here was, initially we had done some early trenching or hydro excavation work for the trench of the electrical conduit. As soon as we did that on the outskirts of the drip line, we found significant root systems, very shallow, very dense. So we knew straight away that we were going to be in for a lot of issue with the excavation. So we actually altered some of those levels and brought the concrete up, because that's all concrete on this side. And then within this space, that basically gave us a bit more depth to be able to provide a base layer of aggregate, which was laid on top of existing soils once the turf was stripped from that surrounding area, so pretty much just straight on. A geofabric layer in between that base course, and the wearing course itself is a aggregate with a resin bound, which actually provides that binding factor to keep it as a hard surface, because this is obviously a trafficable area to the public toilets. So in terms of accessibility, that was part of that, to not have loose stone, but to actually have a permeable resin bound that would provide a hard surface and link into that design intent of having a path that connects all the way around the reserve.
So it just rolls out as you apply tarmac or something, is it? Or is it in sheets? I'm not...
It's like, yeah, it's similar to an asphalt, you could say. So it's mixed in, the aggregate's mixed in with the binder, and basically it's laid and spread by hand.
Yeah. Cheers.
Yeah, definitely. So the product itself is called Stone Set. The installer was SCA Contractors, and they've done a lot of work behind the scenes on that UV stabilisation, because they've had issues in the past with that. Thankfully, this one we managed to get it right, and we've had no colour change in that since install. The question was how we consider silting in that material. So as part of our maintenance schedules, our guys are blowing this quite regularly to keep it clear of debris, and we've also looking at investing in a scrubber, not for just this site but across multiple sites, and we're potentially going to be testing that. We haven't seen it clogged up significantly. A lot of the finer materials are breaking down, and we haven't had any issues to date. Keeping in mind this project's been completed for just over 2 years now, so it's still in its early stages, and we'll continue to monitor that as time goes on, and if there's issues we'll need to look at.